let us see how heap memory is accessed using pointers. Heap memory is accessed dynamically, means the memory is allocated dynamically. The size of the memory required in the heap is decided at runtime, not at compile time. So mostly when we want to allocate memory in heap, we allocate arrays, not just one integer or one float or one character. We will have array of characters, array of floats, or array of integers. So we take arrays. So let us see the difference when the memory is allocated in stack and when the memory is allocated in heap. So I will write down the syntax here. Integer a of size 5, and I will also assign some elements, that is 1, 2, 3, 4, 5. So this is an array. If I write this in our main program, if I am writing this in main function, then this array will be created inside stack, array A inside the stack. That's it. So when you declare an array like this, it will be created in stack. Then how it is created in heap? So for that, I have to declare integer star p. This is one line. I can write it in next line, p assign. Okay, let us finish with this line. When you declare a pointer p, then this p is also created inside the stack. Then next, if I say p assign new integer of size 5, then new means the memory is allocated from heap. So I'll get an array in heap. So where I get, I don't know. So just I am drawing at random place inside the heap, and the address of this array is stored in p. So this p will be having the address of this one. So when you declare an array like this, it will be created in stack. When you take a pointer and whenever you say new, the array will be created in heap. And when you said new, then you need to take that address in a pointer. So that's what we are taking in a pointer, and we have a pointer here. So that's it. New means memory is allocated in heap, and just declare an array is created in the stack. If you see integer star p, again in the stack. So whatever the variables you declare inside the program, let us say main function, whatever the variables you declare, int, I have declared two variables. All variables, they will get the memory inside the stack. Then when do you get memory in heap? This side, new. When you said new, you will get the memory in heap, and that address should be kept in sub address variable. That's all. In C++ programs, if you are declaring array like this, then this is in stack. And if you are creating an array like this, then this is in heap. The same thing can also be written in a single line. I will rewrite the same thing again, that is star p assign new int of size 5. This is created in heap. So you can write it like this also. Now one more difference between stack memory and the heap memory is that, see, this array, when it is created inside stack automatically, then it will automatically get deleted when it is going out of the scope. But heap memory will not be getting deleted automatically. It will be there as long as your program is running. So if you don't want it throughout the program, you want it for limited time, then you should also deallocate it. Heap memory must be deallocated. This is a very important thing. As you are saying new for allocation, then after some time, if you don't need it, then you should say delete p. But p is an array, as we have created as an array, then you should write down this subscript symbol. Delete p. If it is not deleted like this beforehand, only if I say p assign null, let us see what happens if I set this thing, right, without saying delete. After delete, I can say p assign null, means pointer p is not pointing anywhere. I can say this one. This is okay, but I should not do this at all without it being deleted. If I say p assign null, then the pointer will not be pointing to this memory. Then memory is still there inside heap as long as program is running. So assume that you have a big program somewhere, not in main function, somewhere in other function you allocated, and function has stopped, but program is running, the memory will be as it is. So you must deallocate when you are not using it. Otherwise, if you are not deleting it, then it is called as memory leak problem. Means this memory belongs to your program, and suppose the pointer is not pointing onto that one. I'll assume that it's removed, pointer is not pointing on that one, then it is memory leak. That memory is of no use. There is no pointer and it is not also free. Now one thing, if a pointer is not pointing anywhere, then we say a pointer as null. It's a null pointer. Now I have to show more things. Just let us see. Now let us talk about the accessibility. If I have this array, then I can say a of 2 assign 15. So what happens? A of 2 at this place, 0, 1, 2. At this place, 15 will be written. So I can assign some value there, or I can even read that value, write the value. I can do anything with this array by using its index. Can I access this array also? Yes, you can access with the help of P. How? I can say that P of 2 assign 15. So this is 0, 1, 2, 3, 4. So this place 15 will be written. So you can access P of 2 as if it's an array. Yes, this is an array name. Just like array name, you can access it. So that's the benefits. Once you have a pointer to an array inside heap, you can access it with the help of pointer, and the pointer can be treated as name of an array. Now I will write on the sample code and show you how this works.